Hi everybody, welcome to another video in Trigonometry, section 3.3, circular function. So even though the name circular function, but basically we define 6 trigonometric function again, but in different terms. Right, let's go back to how did we define trigonometric function. So in chapter 1, we define based on the point on any circle. We have the x coordinate, y coordinate, and the distance to the origin is r. So we have x, y, and r. With that, we have sine is y over r, cosine x for r, and tangent is y over x. And cosecant, secant, cotangent are reciprocal of sine, cosine, and tangent respectively. Of course, when we define a quotient or a ratio, the denominators cannot equal to 0. Right, so that's how we define it on a circle, any circle. Right. Now, go to chapter 2, we define trigonometric function on acute angle or for right triangle. So in that case, the angle A, we have opposite to that, adjacent and hypotenuse. Sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent is opposite over adjacent. Cosecant, secant, and cotangent are reciprocal of sine, cosine, and tangent respectively. Right, so those are two different ways to define trigonometric function. Now, we define this, the third option to define a trigonometric function. So in this case, we can go back to the first definition that we use for the circle, any circle. In chapter 1, this is how we define trigonometric function. Now this one, if we restrict that x squared plus y squared equal to 1. So now we focus on a unit circle. Unit circle meaning that it's not only just any unit circle, the unit circle that's center at the origin. Of course, the unit circle, so the radius is equal to 1. So in this case, x squared plus y squared equal to 1. But in general, in any circle, upon x, y on any circle with the radius r, we will have x squared plus y squared equal to r squared for any circle. That's what we have. So in this case, we let the radius be 1. So in this case, r is equal to 1. Now, because x squared plus y squared equal to r squared and r is always positive, so r is 1. Now, since r is 1, we define 6 trigonometric function on the unit circle whose arc length s from the point 1, 0 to x and y as follows. Now, little subtle thing when we do on the definition here, if we use a circle, define that for any circle, we use theta angle for an angle. For the acute angle, we use a letter. And here, it is defined based on the arc length. So the strict function now defined on the arc length. On the arc length is radius equal to 1. So remember, previous section we have the arc length is equal to r times theta, right? Now, if r is equal to 1, to s equal to theta. Of course, the unit is different. The unit of s is the unit, the length of length, and theta is radian. So that's different here. But in terms of magnitude, s is equal to theta. The units are not the same, but they quantity-wise they are equal. If r equal to 1, then s equal to theta. So in this case, instead of defining a function based on theta, we define the function based on the arc length. So now, and finally, once we establish that, this definition, if we just let r equal to 1, we have y for sine, x for cosine, tangent y over x, and then the reciprocal function. So pretty much if we let r equal to 1, we have from this definition to that definition. But the way we define the circular function here is not based on the central angle, but based on the arc length. Meaning, we're talking about this. This is S. The length of this arc is S, corresponding to center angle, and since the radius is equal to 1, that's why we can have that. Alright. Okay. Now, once again, we let r equal to 1 and we have this definition, but visually, what do we have? So we have theta, the arc length, and the radius is 1. Now with that, we have the point here. This distance from the point to the x-axis, so this is y. This is y, and because y is equal to the sine values, so we have y equal to sine of s, which is this length here. And because that will be cosine, but I'm going to draw over here. Distance from a point to the y-axis. So here I will do the same thing. Theta. And this is the arc length, S. So the trig function we define based on the arc length, S, where the radius is equal to 1. Right. Now in that case, this is the x values, which is cosine or cosine of S. So the y values is sine, the x values is cosine. Right. How do we define the rest? Right. First, let's consider this length here. What is that? Now, if we set up the math, this right triangle and the big right triangle are similar, right? Yeah. This little triangle and the big triangle are similar, so we can set up the ratio. And by the way, this is x. X. And that is y. So we can set up the ratio. For the small triangle, we have x over 1. X over 1 is equal to y over whatever that is. So that x over 1 is equal to y over that is the similar triangle. Let me write so it's easy to see. X over 1 is equal to y over whatever that is. Now if we want to solve for the question mark is equal to, so whatever this length is equal to y divided by x. And what is y divided by x? That is tangent. So this is tangent. Right. Now, tangent is whatever that is. So when we have an angle, draw the line and draw the tangent to the circle, intercept at the x-axis. That distance is going to be the tangent of the arc length S. Alright, so that is tangent. And if we calculate, this will be what? So that distance is equal to 1 square plus tangent square. So this is secant square. I mean, square root of that is secant. So this is secant of s. Because 1 square plus tangent square is equal to secant square, right? Yeah, so that's why this is secant. So now in the Greek word tangent, in the tangent is from the Greek word mean touch, and secant from the Greek word mean cut. So now from a circle have an angle and an arc length s. We draw a tangent line to the x-axis. The tangent line to the circle intercept with the x-axis. That tangent is going to be the tangent function, mean touch, and the secant is where cut the circle, and that is secant. So that's why we name it tangent, and that's why we name it secant from the Greek word. And similarly over here, if we draw the tangent line to circle intercept at the y-axis, this is going to be cotangent. And yeah, and that will be cosecant. Yes. Yeah, by the way, this line is different than this one. Yeah, if we have to extend that over here to have the same. So this is tangent. This is tangent. This is cotangent. So we have to extend in the point so we can draw the tangent line to the x, intercept the x-axis and the y-axis. Sometimes we have to extend the angle, so we can do that. So that's what this distance is different than this distance. This one is the tangent line to the y-axis, intercept with the y-axis. This one intercept with the x-axis. So this is cosecant. Yes. So that's how we can visualize secant, cosecant, tangent, and cotangent. Right. So in the unit circle. So in terms of math, there's not much different. We just let r equal to 1, and that this definition will become this definition. Right. Now, so, and finally, I said the subtle thing, the way we define this is based on the arc length. The way we define x1r based on the central angle. And the way we define using opposite, adjacent, and hypotenuse will based on an acute angle in the right triangle. So, but after all, I mean, either the way we do that, it's just a ratio. So all of that we have same thing. Right, now let's do some example. Let's s equal to pi, find sine of s and cosine of s. So pretty much we find sine of pi and cosine of pi. So what is sine of pi? Of course, if we look at the circle, where is pi? So I will need to draw a little circle here. So the circle, we know one complete revolution is 2 pi, right? So pi is half revolution. And this point, if it is on the unit circle, notice that this is the unit circle, so the radius is equal to 1. So this point, the x coordinate is -1, the y coordinate is equal to 0. And by our definition, sine is equal to y values, which is equal to 0, and cosine is equal to x values, which is -1. Simple enough, right? Next, let's go to sine of -pi/6. Now let's try to draw a circle. -pi/6. Where was that? So it's going to be here. Go clockwise and to -pi/6. So we talk about this one. With that angle and the length. Right. Even though this defined based on the arc length, but we can still define for negative and positive. Negative, of course, is clockwise, and positive is counterclockwise. Right, so we have that. So notice that, remember, we did something on the previous section, right? So pi/6. So how do we do that? Do you remember the reference angle, right? So reference angle, when we have pi/6, what is the reference angle of -pi/6? In the next part of the section, we'll do that, but it will be just pi/6. So the reference angle, so we write sine of -pi/6 reference angle is pi/6. So first of all, from -pi/6 to pi/6, what we did there, we find the reference angle. And then we determine, is that going to be positive or is that going to be negative? Notice that the points here, sine is equal to the y values. The y values here is negative. So this is negative. So we determine two things. First, the sine is positive or negative based on what quadrant it is on the circle. So this is negative because y is negative. And then second, we find the reference angle. And then we just find the values. Right, so let me just denote negative because of in this point y value is negative. So that's what we have. And then pi/6. Sorry, I should have the hand rule where we have all the trig values, but I lost it. So let's do that again. Sorry. So let's draw a hand. Yeah. 0 degree, 30, 45, 60, and 90. Equivalently in radian, 0, pi/6, pi/4, pi/3, and pi/2. Right? And this is pi/6, and sine is the number of fingers on the right. Take square root of that, divide by 2. So there's 1 finger on the right, so that's 1/2. Square root of 1/2 or 1/2. But again, it is negative 1/2. Right. So find the reference angle, get the values positive or negative, depends on where it is on the circle. Next, we find cosine of -pi/6. So it is related to cosine of the reference angle pi over 6, which is also reference angle negative pi over 6. But on this point, x is positive, right? So this will be positive because x values is positive. And then cosine of pi over 6, pi over 6 is that there are 3 fingers on the left, square root of 3 over 2. By the way, the question did not ask us for cosine of negative pi over 6, but we did that anyway. Right, so we just need to do that. So again, 2 things. Need to consider the side, where the point on the circle, we can determine if x or y is positive or negative. That gives us the sign. And the reference angle, we just get the reference angle, and then we find the values of that. Right. In the next section, next part of the section, we worry about more of the how to find the reference angle effectively. Next, secant of 2 pi over 3. We cannot, it would be easier if we use the reciprocal function. Secant is 1 over cosine. Right. So where is 2 pi over 3? So here's 0, here's pi. 2 pi over 3 is, if we divide this into 3 pieces, 2 pi over 3 will be over here, right? There will be 1, 2 out of 3. So 2 pi over 3 is here. And this point, x is negative, y is positive. Right. And cosine definition is the x values. So in this case, we can just say this equal to 1. And cosine, we can use the reference angle again. Pi over 3. Once again, we go from 2 pi over 3 to pi over 3 as the reference angle. And then we're going to throw in the negative sign because cosine is the x values. The x values of this point on a unit circle is negative. And we just do that. And cosine pi over 3. Cosine is number of fingers on the left, so we have square root of 1 over 2. Which is 1 over 2. So in this case, we have 1 over negative 1/2, which gives us negative 2. Right. So once again, when we're trying to find the trig values, we do 2 things. First, the values will be equal to the trig function of a reference angle. And then the sign, positive or negative, will be defined based on where it is on the circle, which quadrant it is. Right. Now let's try to find all the values and put all together in the unit circle. Right. So we have a unit circle here. Right, just first of all, let's get all the values. We're going to put the degree in the inner circle here and the radian on the outer circle. Let's see if I can. Still doesn't work. Right, so degrees first. Here's 0 degree. And we go 1 complete revolution, so that will be 360. So half of that is 180. And half of the 180, of course, is 90. And here's 270. Right. And then half of the 90 is 45. And so 45, 90, 90 plus 45 is 135. And here's 225. and here 315. Right. And now, if we divide 90 in 3 equal segments, that will be 30, 60, 90, and then another 30 will be 120, 150, 210, 240, 300, 315, and then 330. Here back will be 360. So that's why we have degrees in that. Now, notice that in terms of reference angle. Now focus on this. Didn't draw this very well, but trying to connect this. I'm going to erase this, but I try to draw a circle. I mean, not a rectangle. Like that. Or any rectangle inscribed in this circle. 30, 150, 210, and 330. All of those will have the same reference angle of 30. Once again, all of them will have the same reference angle of 30. And all of them have the characteristic that 330, 210, 150, and 30, they only divide by 30. None of these numbers divide, I mean, of course 60 divided by 30 too, but I mean, it only divides by 30. I remember when we do the reference angle, first we divide by 90. If it doesn't work, go to 60, go to 45, and go to 30. If it is only divided by 30, then the reference angle is going to be 30. 60, even though it is divided by 30, but the reference angle is not 30, because 60 also divided by 60. So we go start with the bigger numbers and going down. Whenever it starts divided by that number, it is the reference angle. So 60 and 90, even though they are divisible by 30, but they divide by 60 and they divide by 90. So that's why it doesn't count. So it is even easier in radian though. So note that those values divide by 30. 60 divided by 30, but it doesn't count. 60 divided by 60 also, so that doesn't count. We look for the biggest number that it can divide by, and that's what we have here. Right. So that is in the degree. And of course, anything, if we can draw a rectangle, all those four we have the same reference angle of those number in the first quadrant. So if you draw another rectangle here, those 4 points in this rectangle, we have the reference angle of 60, namely 60, 120, 240, 300. The reference angle is 60. And then of course we do the same thing for this rectangle. In this case, actually it is a square. So that's the first thing we observe. Next, now if we draw the angle in terms of radian, 0 radian, 1 complete revolution is 2 pi, so this will be a pi. Half of that, pi over 2. And here will be 3 pi over 2. Let me zoom out. Yeah, it's a little bit small, but at least we see the whole circle. Right, now, half of the pi over 2 is pi over 4. And then 1 pi over 4. Now let's just write 0 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, and so on. If we keep running like that, 2 and pi over 4 cancel out, that pi over 2. That cancel will be pi, just pi, but we have pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4 is pi, 5 pi over 4, 6 pi over 4, 7 pi over 4, and then 8 pi over 4, which is 2 pi. Right. Now, if we divide this into 3 equal pieces, pi over 2 divided by 3 will be pi over 6. Right. And now let's just write again. If we have to write 0 pi over 6, 2 pi over 6 will reduce to pi over 3. Three pi over 6 will reduce to pi over 2. 4 pi over 6 will reduce to 2 pi over 3. And then 5 pi over 6 is irreducible. And just keep going. 6 pi over 6 is a pi. Now 7 pi over 6. 8 pi over 6 will reduce to 4 pi over 3. 9 pi over 6, 3 pi over 2. There's 9 already, so 10 will be 5 pi over 3. Right? So 10 pi over 6, 10 and 6 cancel out, 5 pi over 3. And then 11 pi over 6 is irreducible. Now, with that we do the same thing. I draw the rectangle. Just draw one rectangle here, but you will get the idea. If we draw a rectangle in here, all of those at the corner of the rectangle, at the vertex of the rectangles, pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6, all of those will have the same reference angle of pi over 6. So pretty much we just draw rectangles, and whatever the points are on here, on the first quadrant, will give us the reference angle. So the reference angle of all of those 4 will be just that. And one even better things that when we write in radian, as you see, if we draw a rectangle, divide by 6, divide by 6, divide by 6, divide by 6. Let's draw another rectangles here. So if we draw rectangles, pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. The common here is they all divide by 3. And also another common is all of them have the reference angle pi over 3. So now think about this. In the unit circle, just draw rectangles. All of those points on the vertices, we have the same reference angle in the first quadrant. In the case of radian, in the case of spatial angle of the multiple of 30, 45, and 60, all of them divide by 6, we have the reference angle of pi over 6. So I don't have to, I can say, what is the reference angle of 113 pi over 6? You don't even need to know where it is. It is reducible, right? I mean irreducible. It cannot reduce any further. 113 is not divisible by 6. In that case, the reference angle is pi over 6. If it is the reduced number and this is divided by 6 and pi over 6, then the multiple of pi over 6, so pi over 6 is the reference angle. All right, try another one. How about 100 pi over 6? First of all, this is not reduced irreducible, so we can reduce this will be 50 pi over 3. Now, you cannot reduce this any further. 50 and 3, we cannot reduce that. And so if it is irreducible and we have 3 at the bottom, then we can say the reference angle is pi over 3. It works if it is pi over 3, pi over 4 or 6, so we have 3, 4 or 6 at the bottom. That guaranteed to work like that. If it is irreducible and it ends up with 3, 4 or 6 at the bottom, as we have some pi over 3, 4 or 6, then the reference angle will be pi over 3, pi over 6, pi over 4. So that's an advantage of doing this. We don't even know where it is on the unit circle. The reference angle is pi over 6 without doing anything, right? But make sure that whatever it is, the numbers have to be reduced. It cannot reduce. The numbers have to be irreducible. I mean, it cannot reduce any further. Right. Now, the interesting part is the values. How do we write the values? Right. Now that is easy. That's because do the right hand rule. Now let's focus on the first quadrant. I will zoom back in. Normally that I'll focus on the first quadrant only here. Right, in the first quadrant only. In the first quadrant, 0, the point here on the unit circle, the coordinate will be x equal to 1, y equal to 0. That is the coordinate of this point, right? Now the way we write the coordinate here is based on the definition. Once again, let's write the definition. Cosine is equal to the x values, which is the first one, and sine is equal to y, the second one. So in this case, we say cosine of 0 is equal to 1, sine of 0 is equal to 0. Yeah, of course, I'm talking about the radian measure here. Right, so what will be this point? So the coordinate of this point, that is pi over 6 or 30 degrees. And so cosine is the number of fingers on the left. Square root of that divided by 3. So we have square root of 3 over 2. And then sine is the number of fingers on the right, divided by square root of that divided by 2. So that's why we have cosine and sine on the left and right will be left and right, x and y. Right. 45 degrees or pi over 4. 2 fingers on the left, so we have square root of 2 over 2. And then 2 fingers on the right, square root of 2 over 2. For this point. And then next for this 60 degree or pi over 3. 1 finger on the left. So be 1 over 2. And then 3 finger on the right, square root of 3 over 2. And this point back will be x equal to 0, y equal to 1. Right. So that's what we have in the first quadrant. Easy enough, right? Now we're going to draw that for the whole circle. Let's focus on this quadrant first. Now notice that pi over 6 and 5 pi over 6, those are reference angle, so the values will be the same. The sign may be different, but the values will be the same. So how do we write that? These 2 points, both of them divided by 6, so they should have the same values. So we write the same values. Square root of 3 over 2 and 1/2. Right? So we have 3 over 2 and 1/2. So those points we have the same values. However, because this point is on this quadrant, the x value is negative, or the cosine value is negative. So I have to throw in the extra negative sign only for x. But the values in terms of values will be the same. Same thing here, the values will be the same, but the x is going to be negative. It is negative square root of 2 over 2 and square root of 2 over 2. And the values will be the same except the x is negative. And then this point, the values will be the same except the x is negative. Right. So we take advantage of the reference angle. I said both of them divide by 6, both of them divide by 4, both of them divide by 3, and they are reducible. I mean irreducible, right? Pi over 6, 5 pi over 6, pi over 4, 3 pi over 4, pi over 3, 2 pi over 3. Those are irreducible fractions, and both of them divide by 6, so they have the same reference angle. Therefore, they have the same values. The only thing different is that over this quadrant, the x value is negative, the cosine value is negative. Right, so that's why we have that part of the unit circle. Now, the rest, we can say the values pi over 6 will be 7 pi over 6 will be the same, except the point over here, both of the x and the y values are negative. So, square root of 3 over 2 and 1/2 for this point, but both of them are negative. And square of 2 over 2 is square of 2 over 2. I mean, both of them divide by 4 here, right? So the reference angle will be the same, and the values will be the same, except both of them will be negative. Right, yes. And then this is still the same. 1/2 is square root of 3 over 2. And both of them are negative. Finally, in this quadrant, the values will be the same, except the x value will be positive, but the y value is negative. So we have x value is positive, but y value is negative. X value is positive, y value is negative. X value is positive, y value is negative. And here the point will be, x coordinate will be 0, y is -1, and here we have -1 and 0. Right, let me zoom out, and that's what we have as a unit circle. Right. So not only we have the equivalent of degree and radian, it will tell us the x and y coordinate. Moreover, the x is the cosine and the y values is the sine values. So this is very important. It tells us the cosine and sine values of anywhere in the unit circle. I mean only special values. If we have the point somewhere in the middle, like in the middle here, then of course that's not going to be any nice number. But for the multiple 30, 45, and 60, and in the lesser degree, 90 degrees, we have those special values. And all in radian, pi over 6, pi over 4, and pi over 3. Of course, pi over 2 also, we have special values for those values. Right? So that's what we have from the unit circle. Of course, a lot of things we can get out from this are those divided by 6, irreducible fraction divided by 6. We have the same values as pi over 6. The only thing need to determine is whether it is positive or negative. Right, that is a circle. Right, so later on when you do the homework or even the test and even exams, I recommend that you have the unit circle with you, so the calculation is easy. You can get, like I said, this you can get a lot of information from this unit circle. So have that with you. Right. And the remaining of the section is just write down the domain of this circular function. This, of course, we cannot. We can, but kind of difficult to visualize things. Right. Can place back in. Right. Now, that's the first page. Oh, here. Now, and write down the domain of sine, cosine. Now, if we the way we define it, when we go around and around circle, doesn't matter where we are, we can always get an x values and y values for the circle, right? So in that case, the domain of sine, cosine will be all real numbers. We will go over this more details in chapter 4. Now how about tangent and secant? Now let's write the definition out. Tangent is what? Y over x. And secant, reciprocal of cosine, which is 1 over x. Now both of them divided by x. The domain, of course, denominator cannot equal to 0. So when we say the domain of tangent and secant is that x not equal to 0. If x is not equal to 0 on the unit circle, where is the x not equal to 0? Well, I can tell you where is x equal to 0. Pi over 2, 3 pi over 2. It doesn't work. So in that case, x not equal to 0 is the domain for tangent and secant. So that means the angle is not equal to pi over 2, 3 pi over 2. Of course, if we can go around 5 pi over 2, 7 pi over 2, or negative pi over 2, and so that pretty much anything irreducible and divided by 2. On the integers like 5 pi over 2, 8 pi over 2 is reduced to 4 pi, so that doesn't count. Any irreducible when divided by 2 with pi to it. Right. Like I said, we'll go over this in chapter 4. Cotangent is x over y, and cosecant is reciprocal of sine, so 1 over y. And since we divide by y, y cannot equal to 0. And on the unit circle, these 2 points have y equal to 0, so we cannot have those two. So let's just write. In this case, we cannot have these 2 points for tangent and secant. For cotangent and cosecant, we cannot have these 2 points. I mean, we cannot have those points. So s cannot be equal to 0, pi, 2 pi, pretty much any multiple pi. We cannot have that. So when we define based on x, y, and r, then we can write the domain for the problem is easier like that. But like I said, we'll focus more on that on chapter 4. But in this section, the most important is now that we define the trigonometric function on the unit circle, define a trigonometric function for the arc length corresponding to the unit circle where the radius is 1. And this is the definition. Sine is y, cosine is x, tangent is y by x. That's still the same as before. And then the reciprocal function. And then we study about the unit circle. Like I said, from now on, when you take the test or do the homework, I recommend you have that with you. Right. Finally, the way I do the unit circle back in the day when there's no internet yet, and I don't have the trick with the right hand. This is where I remember. So let's just draw the circle first. Now this is another way to get the values of on the unit circle. Now, as we mentioned before, since we can use the reference angle, all we need to worry about is the values in the first quadrant. We can deduce the rest of the unit circle based on the first quadrant. The values will be from the first quadrant, and then the other one will be just change to positive or negative, depends on what quadrant it is. So there will be, and then I know this will be 3 marks corresponding to pi over 6, pi over 4, and pi over 3. Now, back when, like I said, when I studied this back in high school, and of course there's no internet yet, I don't have the right hand trick. Here's what I do. Right, the x values. Right, let's look at the x values first. This one is the biggest x values. It gets smaller, smaller, and smaller as it goes along. Right, so the x values will decrease. Start with 1, and then pi over 6 will be a little less, pi over 4 even less, pi over 3 will be less than that. So if we're counting backwards, and we go from 0, because it is decreasing, it can have 0, 1, 2, 3, and 4. It is decreasing. I know that back to this point, x is equal to 0. So those are the values. Right. But of course, we're not going to be like that. Take the square root, divide by 2. And now this will be the same as the hand trick. So those are the x values. Those are the x values of this point. Now the y values of this point, originally the y values here will be 0, and it will be increasing 0, 1, 2, 3, and 4. And once again, we take the square root. So notice that as we go counterclockwise in the first quadrant, the x value is decreasing. The y values is increasing. So that's why I have 0, 1, 2, 3, 4, and then 4, 3, 2, 1, 0. Yeah. So that's how I studied back in when I was in high school. Of course, now we have the hand trick, but you can use that also. Where was that? But anyway, now that we have the unit circle, we just refer to that. But anyway, that is the focus on this section. Of course, the unit circle. And I will end this section right here. As always, thank you for watching. See you in another video in trigonometry.